So first up here, we are looking at symmetry of an equation. So we're given an equation of a circle here, x minus 3 squared plus y squared equals 4. And first we do a graphical analysis. So I graphed this on desmos.com/calculator, and you enter it in just like this. You'll use carets to get your exponents here. So let's go ahead and do that real quick. So here I'm at desmos.com calculator, and we want to just enter in here. We've got an x, and then I'm going to do a caret squared. And what was the rest though? X minus 3 squared plus y squared equal 4. So we'll get rid of our exponent there. So x minus 3, let's go ahead and open parenthesis. And we'll close it, and now caret 2, arrow to the right, plus y, caret 2, arrow to the right to get out of the exponent equals 4. So there's our circle. Now what you'll notice about this graph is that we have some lines of symmetry here. Notice that the y-axis is the x-axis is a line of symmetry. It cuts the circle in half. So that's the only horizontal line of symmetry. So we've got x-axis symmetry. And then y-axis symmetry. So we look at our y-axis here. It doesn't even touch the graph. We do have a vertical axis of symmetry, which is right here at x equal 3. But they're only having us check for x-axis, y-axis, and origin symmetry. So the y-axis does not cut the graph in half. So that is not a line of symmetry. And then also we want to check for origin symmetry. So lines that go through the origin, we want to see if they hit on the graph in points that are the same distance on each side of the origin. And they don't here. We have points up here, but we don't have corresponding points down there. So as opposed to if we had a circle that was, say, centered at the origin, like so, then we would have origin symmetry. So you draw a line through the origin, and we've got a point here, and then we've got a corresponding point, same distance on the other side of the origin. That's origin symmetry graphically. So no y-axis and no origin symmetry. So we should expect that our algebraic test will give us the same results. So algebraically, test for y-axis symmetry, you replace x with negative x in the equation. So in the equation here, so we'll replace that x with a minus x. So minus x minus 3, that gets squared, plus y squared equals 4. And we want to simplify that and see if it's the same as the original equation. Well, we've got two negatives here, so we can actually factor out a negative. So we can pull out a -1 in front and leave an x, pull this negative out, so plus 3. And that whole thing gets squared. Plus y squared equals 4. And then if you square this -1, you get a positive 1. So this just gives us x plus 3 squared plus y squared equals 4. So that's simplified. That is not the same as the original equation. So this is not the same, not equivalent. So no for y-axis symmetry, which is what we saw up here, no y-axis. For x-axis symmetry, you switch y with negative y in the equation. So we're going to swap out this with a negative y. So we had x minus 3 squared in the original equation plus, and now we're going to put minus y quantity squared equals 4. And then negative y times negative y is positive y squared. So this is x minus 3 squared plus y squared equals 4. And that is equivalent to the equation we started with right up here. That's equivalent. So we do have x-axis symmetry. So this is a yes. And then origin symmetry, you're going to swap out y with negative y and x with negative x. So we're going to have this piece and this piece. So it'll be minus x minus 3 squared plus minus y squared, square outside the parenthesis, equals 4. And we simplify this and see if it's the same as the original equation. So in this piece, we're going to factor out the negative like we did here. Square that negative 1, we get a positive. So we've got x plus 3 squared. And then a negative y squared is the same as positive y squared equals 4. This is not the same as the original. The original had a minus in there. So this is not the same. So we do not have origin symmetry algebraically. And they are also going to have us find some intercepts here. So for x-intercepts, let's see, to do the x-intercepts, you want to set y equals 0. So this actually should be the other way around. Because the x-intercept is the x-coordinate when y equals 0, and the y-intercept is the y-coordinate when x equals 0. So if we set y equals 0 in the original equation, let me grab that and bring it down. So here's our original equation. So if you set the y equals 0 here, we'll get x minus 3 quantity squared plus 0 squared equals 4, which is really x minus 3 squared is equal to 4. And then we can solve this by taking square roots. So square root on the left equals square root on the right. So we get x minus 3. And then there's a positive and negative square root of 4, so plus or minus 2. And now let's add 3 to both sides. So this 3 will come over as a positive. So x will be 3 plus or minus 2. So 3 minus 2 is 1. And then 3 plus 2 is 5. So your intercept points here are going to be 1, 0. And 5, 0. So x coordinates when y is 0. And then for our y-intercepts, we are setting x equals 0 in this equation. So we get 0 minus 3 quantity squared plus y squared is equal to 4. And negative 3 squared there is 9. So 9 plus y squared is equal to 4. And then subtract 9 on both sides. So bring that over as a negative. So y squared will be 4 minus 9, negative 5. And then if we take square roots and try to solve, we do not get real numbers. So this has no solution in real numbers. So that's empty set, no solution. No y-intercepts here. And if you go back up and look at our graph here, we can see we've got those intercept points here at 1, 0 and 5, 0. But we don't hit the y-axis. No y-intercepts. So 2 x-intercepts, no y-intercepts.